Tonkumat Online Academy. Today we want to talk about a special type of function that we call mapping. Mapping is a set of or a group of two sets, usually what we call non-empty sets, where each of the elements in one of the sets has something that is linked to in the second set. I say that each of the elements in the first set has another element that it is linked to in the second set. The first set is called domain, while the second set is called codomain. Now, the element in the codomain that the element in the domain is linked to is called the image. So within the codomain, we have the images of the elements in the domain. Within the codomain, we have the images of the elements in the domain. Now let me show you what I mean by this. Now, if you have something like this, or let me rather use this. If you have something like this, now we have A here, we have B, and we have C, and we have 1, and we have 2, and we have 3. Now, every element in this one is the first set, and this one is the second set. Now, every element in the first set has another element that it is linked to in the second set. So A is linked to 1 here, B is linked to 2, and C is linked to 3. Now, this first element is called domain. Why the second element, the first set is called domain, why the second set is called codomain. The first set domain, why the second set is called codomain. Now, the rule now is that every element in the domain must have only one. Every element in the domain must have only one element in the codomain that it is linked to. If one element in the domain is linked to more than one element in the codomain, then it is not a mapping function. Each element in the domain must have only one element in the codomain that it is linked to. For instance, we can have this ABC 1, 2, 3. Then we have A linking to 1 and A linking to 2 and B linking to this. Now here, this is not allowed. This is not allowed because this A is linked to two elements in the codomain. This is the domain, and this is the domain, and this is the codomain. So every element in the domain must be linked to only one element in the codomain. But here we have A which is an element in the domain, linking to two elements in the codomain. So this is not allowed. So this one is not a mapping function or a mapping, or is not even a function, because one element here is linked to two elements in the other side, in the codomain. Now, another rule is that no elements in the codomain, in the domain, must be left unlinked. So because this C here is left unlinked, there is nothing that it is linked to in the codomain. Now, this is another way of disqualifying this thing from being a function or a mapping. Every element, this one must be linked to something again for this thing to be a mapping. So if there is an element in the domain that is not linked to another element in the codomain, then it is not a mapping function. Now, but note that an element in the codomain can have more than two or more than one linking. So it is possible for us to have something like now it is possible for us to have this where two elements in the domain is linked to the same elements in the codomain. Two elements in the domain are linked to the same elements in the codomain. This is possible. Now, just the simple trick or something you can use to remember the difference is that in domain we cannot have V, but in codomain we can have V. What I mean by V is a shape that looks like V. So a shape that looks like V, like here having V shape like this, is not allowed in domain, where V is a link to two different things in the subdomain, in the codomain. It is not allowed, but a V shape is allowed in codomain. So we can have now this V shape now is showing that one element in the codomain is linked to two elements in the domain. So this is what you use to remember the difference in the rules. One element in the codomain can contain or can be linked to two elements in the domain, but no one element in the domain can be linked with two images in the codomain. I've defined what is meant by domain, and I've also defined what is meant by codomain, and also what is meant by image. An image is the elements in the codomain that an element in the domain is linked to. Like this A is linked to 1, so 1 is the image of A in the codomain. The codomain contains the images. B is a codomain here. Now, it is possible for us to have an element that is not an image in the codomain. That is, it is possible for us to have excess image in the codomain, and I mean excess element in the codomain. That is an element that is not linked to any element in the domain. But remember that this is not allowed in the domain. Every element in the domain must be linked to something in the codomain. But for codomain, we can have some element in the codomain that is that are not linked to any element in the domain. So we can have something like one, two, three, four, A, B, C. Now this is allowed where we have extra element in the code domain, that is the number 4, which is not linked to anything in the domain. The ones that are linked to something in the domain, they are called the images. Now the one that is not linked to anything in the domain is not an image. It's not an image of anything. It is only called an image when it has been linked to an element in the code domain. So 1, 2, 3 are images. Number 4 is not an image of anything. So it is just there, but this is still a function. This is a function, but if it is in the domain side, this is not allowed. Everything in the domain must be linked to another thing. So this one is allowed. Now, what we mean by range is a group of all the images in the code domain. So when we bring out these 1, 2, 3, which are all the elements in the code domain that are linked to something in the domain, we call them a range. So a set that contains the images that are linked to the images of the domain, the set is called a range. A set that contains the images of the domain is called a range. So here we have talked about the domain, the code domain, the image, now the range. Now one-to-one mapping. One-to-one mapping is when we have just one element in the domain mapping to one element in the code domain. Now you remember that one element in the code domain can be linked to more than one element. If only the elements in the code domain are linked to one element in the code domain, it is called one-to-one mapping. For example, now here, each element in the domain is linked to one element in the code domain. That is, A is linked to only 1, B is linked to only 2, and C is linked to only 3. Now, this is a one-to-one mapping. Nothing in the domain is linked to 2 elements. So this one is a one-to-one mapping. Now, onto mapping. Onto mapping. What we call onto mapping is when all the elements in the code domain are linked to something in the domain. That is, nothing is left unlinked in the code domain. We call it onto mapping. Now, if you have something like now this thing again is onto mapping because A is linked to 1, B is linked to 2, and C is linked to 3. We have 3 elements in the code domain and each of them are linked to something in the domain. We call this an onto mapping. Now, if you have something like this, now this one is not onto mapping because we have number 4, which is not linked to anything. So not all the elements in the codomain are linked to something. Therefore, this one is not an onto mapping. Now, let me also say something about the one-to-one mapping. In this one-to-one mapping, if you have something like now, this one is not one-to-one mapping because two elements in the domain are linked to one element in the codomain. In one-to-one mapping, one element in the domain is linked to only one element in the codomain. 1, A is linked to 1, B is linked to 2, and C is linked to 3. But here we have two elements in the domain linking to just one element in the codomain. This is not allowed in one-to-one. So this one is correct. This one is not correct for one-to-one. And for onto mapping, this one is correct, and this one is not correct. Onto mapping. So this is really all about this onto mapping and one-to-one mapping. Now the questions can come this way. They can put it in the function notation. Now the notation for mapping is this. Now, the mapping notation or function notation, when we write something like this, what it means is, or how it is read, is that function f from A to B, function f from A to B. This is how to write the function linking one set to another set. That is the domain to the codomain. Function f from A to B. Now, remember that we've discussed about quadratic function. It is just the same thing with mapping. Only that in mapping, instead of writing y equal to something, we are now using a set to represent the two different. In mapping, each value of y is grouped as a set, and each value of x are also grouped as a set. So it's just the same thing that we do in normal equations that we have in mapping. But instead of writing y equal to x plus 1, we put all the values of y as a set and we put all the values of x as a set, and then create a rule that links each of the values in the y with a value in the x. That is what we call mapping. A function in which we have two sets and we have a rule that links every element in one of the sets to another element in the second set. So when we have the values of, maybe we are told that x is a range of number within 1 to 4. Now that means that y, when x is equal to 1, let's solve that one. Assuming that we are told that y is equal to x plus 1, and we have that x is value from 1 to 2, or let's say now where we have x is this value, or takes these values, x from 2 is less than or equal to x, and x is less than or equal to 3.